Hi guys, my name is Badrinath, ECE department from Johnson's Institute of Technology. Today my case study topic is Nd-Yag.Laser processing in ceramic industries. We can go through it and we can analyze this topic in detail. First of all, Nd-Yag.Laser, neodymium doped yttrium aluminum garnet as Nd-Yag. Laser is a solid state laser in which Nd-Yag is used as a laser medium. Nd-Yag.Laser in ceramic industries. First we can see it's in ceramic industry. Technical ceramics such as Al203 can be found in many fields of human activity. Significant exploitation of ceramic is also in medicine as orthopedic implants are made from it. Due to its characteristic properties like high hardness and brittleness and high thermal conductivity and wear and chemical resistance, and it is hard to machine it by conventional methods. Laser machining ceramics is the actual issue for many applications including cutting, drilling and scrubbing. Lot of laser parameters, mainly pulse length, peak power, pulse energy, pulse frequencies, and materials and method. The first laser source was flash lamped pumped Nd-Yag.Laser LASA KLS 246102 emitting at wavelength of 1064 nm. We can obtain laser spot in focus plane 0.6 mm allowing maximum power 150 watt. Firstly, fixed parameters during the process were frequency 20 Hz and pulse length 0.5 ms. The pulse length was increased from 0.6 ms to 1 ms with the increment 0.1 ms, namely for each value from the interval of flash lamp voltage YLR 150 or 1500 QCV as IPG with a multi-mode core fiber that can work at pulse mode providing various pulse lengths and high peak powers, and as well as its continuous wave mode providing high average powers. You can see here is a two tables that process parameters for drilling aluminum ceramic using Nd-Yag.Laser. Here voltage is 250 to 300, pulse length, pulse energy, energy density, average power, peak power, power density. See, those are the drilling aluminum ceramics by using our Nd-Yag.Laser. You can check it also in table 2. That also same, but here we are using QCV fiber laser. Pulse length is 0.5 to 1.0, and see that pulse energy, energy density, average power, peak power, power density. You can go through these tables, you can get a better clarity. For experimental studies, aluminum ceramic Al203 purified 96%. Plates with thickness 2 mm were used. Before starting experiments, the sample surfaces was cleaned by acetone to remove oil and dust residues. It is the important thing. I have to clean it first. Tests were performed at ambient temperature in air with the aid of compressed air supplied at pressure. 2 bars holes diameters and depths were measured with the help of scanning. Confocal microscope Olympus Lext 3100. Measurements of dimensions and 3D reconstructions of the irradiated surfaces were provided by attached software. Results and discussion. Our results and discussion. We can discuss that that means the result. Laser drilling is a complex process. Depend on several laser parameters. Therefore, there could be problems with melt producing during the drilling. Yes. The shape of the hole is affected by melt explosion, and irregular or incomplete explosion causes formation of recast layer and can even close the hole in this paper. Modifications of the several holes. Geometry are analyzed under several process conditions. The effect of wavelength, pulse energy, pulse wavelength, peak power, and number of pulses on the holes. Characteristics were investigated. Ceramics drilling using Nd-Yag.Laser. Dependence of the entrance holes diameter drilled in aluminum ceramics on the pulse energy for three selected number of pulses is presented. The graph also shows that the number of pulses is not a decisive parameter as its influence on the hole's diameter was not significantly proved. By setting different values of pulse energy, the required holes with entrance diameters between 374 mm and 537 mm were created. The exit holes diameters did not exhibit clear dependence on pulse energy and their dimensions were between 200 mm and 300 mm. Here you can see this graph. This is the hole diameter and horizontal is pulse energy. You can see those colors and the shape boxes and understand this graph. This phenomenon arises from the melt explosion from the cavity. However, more pulses cleans the cavity and drops of melt disappearance from the exit hole. Thus, the increase in the number of pulses does not significantly affect the hole's diameter but can affect the amount of the recast material. Also shows that the entrance holes are quite circular while the exit ones have non-circular irregular shape. However, circularity of exit holes could be improved by increasing the number of pulses. And here you observe this A, B, C, D images. Here the diameters of the holes drilled in aluminum ceramics. Those are the holes drilled by aluminum ceramics by Nd-Yag.Laser. In dependence on pulse energy for number of pulses 80, 100 and 120 by keeping frequency 20 Hz and pulse length 0.5 ms. Image of the hole generated by Nd-Yag.Laser using charging voltage of flash lamp 250 volt and 280 volt. Longer pulse length also improved the exit holes quality as the hole is becoming more circular. And observe this graph is very important for understanding. You can get a better understanding from this experiment and this phenomenon has its origin in the melt erosion of the hole sidewalls induced by the high pressure of vapor located nearby the material surface within radiation. The pressure in the material up and away from the hole. However, these imperfections can be reduced by using longer pulses and higher energies. From our observations, it can be conducted that relativity long pulses 1 ms with pulse energy 3,4 Jan energy. Densities about 1 kJ per centimeter square are the right parameters for aluminum drilling by Nd-Yag.Laser. And this is the main topic, ceramic drilling using QCV fiber laser. You have to concentrate on this. We are discussing about QCV fiber laser. QCV fiber laser was the second laser used to drill. It is the second laser, aluminum ceramics. The hole's diameter was investigated the dependence on pulse energy, peak power, pulse length and number of pulses. The dependence of the hole diameter on the pulse length is depicted. If the smaller diameter and the high circularity are needed, the short pulses and high peak powers of QCV fiber laser should be settled. And the finally conclusion, friends, the result shows that it is possible to control the holes dimensions by changing laser and their parameters. It was possible to create holes with diameters in the range from 350 mm to 600 mm using Nd-Yag.Laser and from 133 mm to 266 mm using fiber laser. read this calculations, that means these readings for 350 mm to 600 mm using Nd-Yag laser and 133 mm to 266 mm using fiber laser. Thank you friends. If I make any mistakes, leave it friends. Thanks for watching.